Hello dear students of +1 medical and non-medical respected teachers. Today I am going to discuss a very important topic, capillarity or capillary action, its applications and a very important derivation of a formula known as Ascent formula for surface tension. So let us discuss. So spend 10 minutes with me. Watch the video completely till end and you will understand each and everything about capillary action and Ascent formula. So first of all, what is capillarity? No, what do you mean by capillary tube? A very fine bore tube of glass open at both ends having diameter of the order of millimeter is known as a capillary tube. Now when a capillary tube is dipped in a liquid contained in a vessel, then liquid may rise or may fall in the capillary tube. So this rise or fall of a liquid in a capillary tube is known as capillarity. So suppose we have water and dip a capillary tube in it, you see water rises in the capillary tube, attains some height above the free surface in the outer vessel. If we take mercury and dip a capillary tube in mercury, then mercury will fall in the capillary tube as compared to the height in the outer vessel. So those liquids which wet the surface of glass rise in the capillary tube, whereas those liquids which do not wet the surface of glass fall in the capillary tube. So water rises in the capillary tube, mercury falls in the capillary tube. So this rise or fall of a liquid in capillary tube is known as capillarity. Now there are so many applications of this capillary action. First application, rise of moisture through the roots of the tree is due to capillary action. So roots of the tree act as capillary tubes, and that's why moisture rises from the ground into the tree. Rise of oil in the wick of a lamp. So wick of lamp also acts as capillary tube. There are large number of capillary tubes in the threads of the wick of the lamp. So oil rises through the wick of the lamp due to capillary action, and that's why it ignites continuously. A damp proof layer is laid while constructing buildings. Very important. So when we have to construct buildings, so we have to put a damp proof layer of concrete, charcoal, of any insulating material, so that moisture doesn't rise through the bricks, because in bricks there are large number of capillaries. There is capillary action. So a damp proof layer is laid while constructing building to avoid moisture, so that our paint does not get damaged due to capillary action. Plowing of fields after rain. We plow our fields to restore rainwater for long time, because due to plowing our fields, capillaries break and capillary action stops. That's why we plow our fields to restore rainwater for long time. Action of blotting paper is also based upon capillary action. A fine slit is provided at the nib of ink pen. The principle of ink pen is based upon capillary action. So we write due to ink pen, and ink is due to capillary action. So slit is provided for capillary action. So there is difference between principle of ink pen with a nib and principle of a ball pen. So ball pen is based on principle of gravity. So you cannot write with the ball pen when it is vertically upward like this because of gravity. So ink will not rise, but you can write by holding ink pen vertical and on the top of the vertical paper. So this is again capillary action. So then we come to very important formula known as Ascent formula. So Ascent formula is an expression for surface tension. To understand, suppose we have a liquid, say water, in a large vessel. Let a capillary tube of radius r is held vertical so that a part of the capillary tube is dipping inside the liquid water. It looks like a tube of large radius, but to make diagram clear, I have made it a big diagram. But basically, this tube is of very fine diameter, very fine radius. It is made up of glass, open at both ends. Then, due to capillary action, liquid starts rising in the capillary tube. So this liquid rises in the capillary tube until the weight of the liquid column in the capillary tube above the free surface in the outer vessel. This weight of this liquid column becomes equal to the force due to surface tension, because liquid rises in the capillary tube because of force of surface tension, and it will rise till the weight, because weight acts vertically downward, balances the force due to surface tension. So suppose AOA dash is the meniscus of the water liquid in the capillary tube. EF is the tangent drawn at the bottom of the meniscus. H is the height attained by liquid in the capillary tube. Now, consider molecule A, which is in touch with the glass wall, just above the meniscus of the liquid AOA dash. Then draw a tangent AT to the meniscus, because force due to surface tension acts along the tangent to the meniscus, and due to Newton's third law, to every action there is an equal and opposite reaction. So a reactional force acts along AT dash, which is equal to sigma in magnitude. So this reactional force acts every point along all the sides of the capillary tube, everywhere. Let theta is equal to angle of contact. So angle of contact is the angle the meniscus at the point of tangent to the meniscus at the point of contact makes with the glass wall. That is, AT makes with the vertical glass wall. This is called angle of contact. If this is theta, this is also theta. It means this R is equal to sigma acting along AT dash can be resolved into two rectangular components. Sigma cos theta vertically upward along the walls of the capillary tube, sigma sin theta perpendicular to the walls of the capillary tube, and sigma cos theta, sigma sin theta acting everywhere on the capillary tube. But sigma sin theta, they are acting normal to the capillary tube, not the walls of the capillary tube. It means these components are not responsible for the rise of the liquid in the capillary tube. So we can ignore them. So there is no effect of these components sigma cos theta which are acting outwards normal to the capillary tube, walls of the capillary tube. But sigma cos theta are acting everywhere in the vertically upward direction. So this means this total force responsible for the rise of the liquid in the capillary tube is given by F is equal to sigma cos theta into 2 pi r, where r is the radius of the capillary tube. Sigma cos and 2 pi r, this is equation number 1. So total force experienced or responsible for the rise of liquid in the capillary tube is given by F is equal to sigma cos theta into 2 pi r. Sigma is the surface tension of liquid, that is water. Theta is the angle of contact, which is always less than 90 degree, and it is very small, about 8 degree for pure water and pure glass, nearly 0 you can say, or r is the radius of the capillary. This is equation number 1. Now, which weight balances this force? Now we have to find a weight which balances the force into surface tension, and then we compare them and we'll get the formula. Only 2 steps. Now to find weight of the liquid column, so we'll divide this portion into 3 parts. First of all, we find the volume of the liquid column of height h and radius r. So there is cylindrical volume because it is a cylinder of height h and radius r. So total volume of the liquid column in the capillary tube above the free surface in the outer vessel is given by V is equal to volume of the liquid column of height h. Volume of liquid column of height h and radius r, plus volume of liquid column of height r and radius r. But this half of the sphere is empty, so minus half of the volume of the sphere of radius r. So that will give you exact volume between this meniscus AO dash and the walls of the capillary tube above the free surface in the outer vessel. Exact. So V will be equal to volume of cylinder of height h and radius r plus volume of cylinder of height r and radius r minus half the volume of sphere of radius r. And volume of cylinder of radius r and height h pi r square h plus volume of cylinder of radius r and height r pi r square r, and minus half the volume of sphere is 4 by 3 pi r cube. So you simplify it. So pi r square h, pi r cube is common, 1 minus 2 by 3, it will be 1 by 3 pi r cube. So total volume of the liquid column in the capillary tube above the free surface in the outer vessel is given by pi r square h plus 1 by 3 pi r cube. Therefore, weight of liquid column in the capillary tube is given by W is equal to volume into density into G. So V rho G. So pi r square h plus 1 by 3 pi r cube into rho G. So this weight balances the force due to surface tension. So 1 must be equal to 2. So sigma cos theta into 2 pi r is equal to pi r into r h plus 1 by 3 r square rho G. So pi cancels, 1 r cancels. So we get sigma is equal to r h plus 1 by 3 r square rho G upon 2 cos theta, which is the exact Ascent formula for surface tension. But since radius of capillary tube is very small as compared to height attained by liquid in the capillary tube, so r is less than h. So 1 by 2 r square, 1 by 3 r square will be very small, that is 0. 1 by 3 r square will be approaching to 0. So therefore, we have sigma is equal to r h rho G upon 2 cos theta, because 1 by 3 r square can be neglected. So which is required Ascent formula, that is expression for surface tension of the liquid. Now if theta is 0, cos 0 is 1, so RH will be equal to 2 sigma by rho G from this equation. Now at constant temperature, because surface tension depends upon temperature, for a given liquid rho is constant, at a place G is constant, this right hand side 2 sigma for rho G is equal to constant. This implies RH is equal to constant, that is product of radius of capillary tube and height attained by the liquid in the capillary tube is constant, and hence H is inversely proportional to R. that is height attained by liquid column in the capillary tube is inversely proportional to radius of the capillary tube. And this is nothing but Jurine's law. So you may be asked, state Jurine's law. It states that height attained by liquid column in the capillary tube is inversely proportional to radius of the capillary tube. So this is Ascent formula, and angle of contact is less than 90 degree, that is acute for liquid which wet the surface of glass, and greater than 90 degree for liquid which do not wet the surface of glass, like mercury. In case of mercury and glass, angle of contact is 140 degree. In case of water and glass, angle of contact is 8 degree. In case of pure water and pure glass, angle of contact is nearly 0 degree. So this is all about capillary action, capillarity, and very important Ascent formula. And go through this Ascent formula at least twice and drive this relation, and you get question in the examination that drive Ascent formula at least 5 marks. So all the best, be happy, stay tuned, good luck.